Great. Right. That was very professionally done, wasn't it? So, some of you have seen this talk before, including Richard, so he's not missed much. So yeah, I was hoping there were a few more people here that are not BT people, so apologies to the 40% of the audience that this is going to seem awfully familiar. It's like watching Dave or something. Oh, it's QI, but it's a really old one. So, what am I going to talk about? Basically, I'm going to talk about using Unix command line tools to kind of build up processing pipelines for munging data and that kind of thing. I'm going to talk a bit about the Unix philosophy of small, sharp tools and why it makes those tools really work well together to do whatever tasks you can come up with. And then I'm going to do some examples worked through, because live coding never goes wrong. Why did I decide to talk about this? It started when I was preparing a kata, for those who haven't come across katas, it's like a simple programming exercise that you repeat over and again to kind of practice your software development. We're going to do it for some people at work, and I thought, well, I better do it myself beforehand just to make sure I know what I'm doing. And the kata we were doing was something called Weathermonger. This is from Dave Thomas's softwarekatas.com, whatever it's called. So the point of this, you get this file full of loads of data. Most of it you don't really care about. The only bits you have to look at is the first three columns. There's a day number, there's a maximum temperature, a minimum temperature, and the point of the exercise is to write some software that would go through, find the day number, or print out the day number with the smallest difference between min and max temperature. And done this previously. This is a Ruby implementation, so I had a class that kind of wrapped around everything, and because it's trying to do a proper object orientation, lots of other small classes. So I had a weather record class and a data reader class that read the file in, and a range finder class that did the actual work, and a thing that printed the results out. So probably a bit over the top, but like 4 separate classes. Obviously also a bunch of tests as well. And for the kata work, we're going to be doing it in Java. So I thought, well, let's try and implement it in Java. So where do I start? I'll start with an exceptions test. So to write a test that takes the data, makes sure it produces the right number. Well, what's the right number? I guess I could have just run the Ruby one that I've just shown you. But I thought, or I could have just looked down the thing. So I thought, well, it's probably a good excuse to play with awk, because I should learn more about awk. So did a bit of Googling, fiddled around a bit, ended up with this bit of code, which we'll come back to later. Won't make much sense at the moment. It's the command awk, a string of gibberish, and the file name. And when you run it, it prints out the answer 14. So okay, that's good. Put that in my test. And I thought, wait a minute, I've just done the kata. I'm not going to waste my evening doing it in Java now. So I got bored with what I was supposed to be doing. Around about the same time, someone wrote a blog post called "Command Line Tools Can Be 235 Times Faster Than Your Hadoop Cluster." So someone had blogged about using Hadoop, Amazon's, what do they call it, Elastic MapReduce service, to take, I mean, it wasn't really big data, it was a couple of gigabytes of chess game results or something, and he spewed this into Amazon's cloud stuff, did some calculations on it, and it took 26 minutes apparently. And this guy said, well, that seems to be quite a long time, and it looks like the kind of problem you could do with command line tools. So he had a play on his laptop and wrote a few shell scripts and things, ended up getting it down from 26 minutes on something like 6 Amazon servers to 12 seconds on his laptop. So the moral of that story is don't always reach for the big guns when you can just do something using the tools that are there in your shell. So why are Unix commands good for this kind of job? There's a few attributes that most well-behaved Unix commands have got. Generally, they'll focus on doing one thing and doing one thing well. So one command for searching a file, one command for finding files, one command for replacing text, whatever it might be. They work with file streams, so they'll read a file, an input, and they'll output a file, which will become more obvious later. Apologise for people I'm teaching to suck eggs. They expect plain text input, and they output plain text in general. Obviously, things like zip or whatever don't output plain text because that's not their job. So that means that they can easily interact with humans because you can read the output, you can write a file and pass it into them, and they interact with each other because they all expect text and they all output text. And generally do that one line at a time. So each piece of data will be on one line, and they process them a line at a time of the input and put them on the output. So they don't wait for it, don't read a whole file, process it, and then write a file. They take one line, process it, output a line, next line, which makes them quite good for building up pipelines, as we'll see later. They're generally not very verbose unless you tell them to, so you won't get a thing saying, I'm about to read this file, here's the output, and then telling you what it did, because that is a real pain if you're then trying to use that output in something else. They'll literally give you the output you need. So find is a good example. If you try to find a file and it's not there, it'll just return nothing. It won't say, couldn't find the file. But where there are errors, they come out on a separate file stream. If you're just running them in the terminal, both things will be interspersed, but you can take the real output and send it one way and take the errors and send it somewhere else. So if you're actually trying to parse the output, you know you're only looking at the output, you're not looking at the error messages. And finally, they generally all have an exit code which is either 0, which means they worked, or anything non-zero, which means they didn't work. And when you combine them all together, you can easily say, well, only run the next thing if the previous one didn't error, without having to call functions to test things. So I said before, they separate input and output. So this is like standard format of it. Any command takes input from one side and outputs the actual program output and errors. You often hear those file streams called standard in, standard out, standard error. If you're just using it in a shell, standard in will be from the keyboard, and the other two will come out to the screen. But where it gets really useful is when you use pipelines. So that is, contrary to what it says, it is a pipe character. And you use pipes to build up as many commands as you want. You just run a command, the arguments, pipe symbol, next command, it takes a standard output of one and bolts it onto the standard in of the next. So this is where I said it's really useful that they do one line at a time, because as soon as command 1 is finished with its first line, it sends it on to command 2, which is now working on whatever it's doing. So it doesn't take, if you've got 10 commands in a row, they each take a second. It doesn't necessarily mean it's going to take 10 seconds, because if they're taking a second to parse 1,000 rows, then after the first 10 rows have been parsed, all 10 of those processes are busy, they're just one behind each other. So I'm going to run through some useful commands, and then I'll do my example. First one, pretty much everyone who's ever used Unix, Linux, whatever, has probably heard of cat. Everyone knows what cat does, but it's a cat, not really. So cat, generally people use it for printing out files. So say cat, and then a path to a file, and it will just print out the file on the screen. You can give it multiple file names, in which case it will just print the contents of all the files. That's actually why it's called cat. Anyone didn't know it's short for concatenate. What its actual job is to concatenate files, even though most people don't use it to concatenate one file, if that makes sense. If you just run it on its own, as I said before, standard in, standard out. Standard in will be connected to the keyboard effectively. So if you type something, as soon as you hit return, it'll just echo the same line back again and then wait for you to type the next line. It doesn't do it character by character, it just waits for the return character. So type another line, echoes another line, type another line, echoes another line, and eventually you hit Control D, and that's like the end of file marker, so it'll stop. So ways you can use cat. That's what I'm just saying, just using it on its own. Reads from the keyboard, outputs the screen, not very useful. Cat file, will print the file. Cat multiple files, will just print them all one after the other. You can give it a file glob pattern which says print all the files that match that pattern. Technically that's not cat doing that, it's the shell. So that if you had file 1, file 2 and file 3, the actual cat command will receive file 1, file 2, file 3. But it has the effect of taking whatever matches. You can, if you want, say, use a left arrow which says redirect standard in from this file name. It's the same effect as if you just gave it the file name. And if you want to, you can put that in front if you think it reads better. I don't think anyone ever does, but it works apparently. You can also redirect the output. So this command says take file 1 and file 2, concatenate them together and write them to file 3. You can redirect standard error, which is the second file descriptor, so that's what the 2 means. So cat the file contents go to the screen, any errors will go to dev null, so you won't see them, so that's the sort of throwaway file handle. So if there wasn't a file called file 2, called file, you wouldn't see an error message. You can say cat file 1 to file 2, and then this thing just means redirect standard error to the same place as standard out. And there's a shortcut for that just is ampersand arrow. So cat this file and the error messages all into file 2. So I've said that this is things you can do with cat. It's not really just cat. This is basically what you can do with any well-behaved Unix command. So pretty much all Unix commands, or all the ones we're interested in for this sort of work, take a number of file arguments, or they'll read from standard in, and then they'll output a standard out unless you redirect them. So a slightly more interesting command is grep, which stands for global regular expression print, which is from the ed editor, which is even older than vi. So type of thing you might use grep for is treating it crosswords. So if you've got a few letters, you can use the words file on your machine to say what matches that pattern. So in this case, beginning of the line, D, something, B, something else. Depending on those regular expressions, that's what that's using. And that'll print out the word developer. So one thing you sometimes will see is someone will cat a file and then pipe it into grep. So obviously that's an example of using the pipeline, but it's actually a bit redundant because you could just tell grep to take that file in the first place. There used to be something in the old days, I think, of Usenet called the, so that works the same, the Useless Use of Cat Award. So when people posted things saying, oh yeah, just cat this, pipe it into grep, someone would say, you win today's Useless Use of Cat Award. So grep, searching files, sed is the stream editor, so it allows you to actually modify files. Generally not modify the actual file you're reading, although there is an option to do that, but it will take input, it'll make changes to it, and it'll print out the changes. So if we've got a file with those lines in it, and we run this command, so substitute foo with bar, and the /g just means globally. It will look very familiar to any vi users. Then, for anyone who can remember what flashed up on the screen briefly, it used to say foo equals 42, print foo is, so it just changes those. Other basic things you can do is sed, so for example, lines 2 and 3, D means delete, so that will just run that, it will just delete the second and third lines. Or you can say delete any lines that match beginning of the string and then the word good. So that will delete the last line. And slightly more tricky, that says find lines that begin with print and then insert. For some reason you have to do this weird / new line malarkey, but and then insert a hash. So this, from that quote to that quote, is all the same argument, it just happens to have a new line in the middle of it. And you can see where it's found the print line and commented it out with a hash. And this just says append the words end of file. So that just prints that at the end of the file. So if you've got simple things that you need to do with a file, sed can sometimes be quite handy. Although it's Sorry?
Basically, only if you want to edit the
No,
file.
it says it's an expression. It's optional for a single expression.
Okay.
I
It's
don't know.
probably a good idea to put -e.
Yeah.
Otherwise, it can be done as file memo.
Yeah, that's true actually, yeah. I think that does work, but
Yeah, it's a good idea.
yeah. I don't know, you said you're going to heckle. So, good. So find is used for finding files, not for finding things in files. So in this case we say look in the app directory, find any file with a name of star, so anything that ends in controller.rb, and that finds those files. If you are doing this kind of thing, you have to remember to either put this in single quotes or escape the star, otherwise the shell will grab it first and it'll try and expand it into files that don't exist and go wrong. So you're not just restricted to finding by name. In this case, we're looking for anything of type F in that directory, which is file, as in not a directory or a symlink or anything. And I'll just print out the files. If you want to find the directories, minus type D, there's a whole bunch of other ones as well. Man is your friend incidentally. If you want to know anything about any of these commands, just type man and then the command, and it will tell you more information than you ever wanted to know. So yeah, find all the directories under that path. Xargs is a command that takes a bunch of lines, individual lines, and turns them into one long line. So if we run that previous find command that returned all those directories and pipe it into Xargs, that'll just return all the same things but on one line, which doesn't seem very useful, except that you can also give Xargs a command to run. So if we say Xargs du, so du is the command, or du minus ks, is the command that says tell me how many kilobytes that directory uses in total. So we find all the directories and we pipe it into that, which effectively is the same as saying du minus ks and then giving it all those file names as arguments. And that'll do what du does. You can also say like minus n3, which means it'll take every 3 arguments and call the command once for each 3 until it runs out. And you can say minus p and give it a number, which is a number to run in parallel. So if you've got multiple CPUs, it can run the same, 4 instances of the command at once or whatever.
There's another useful one if you want to do with find. If you use
The null thing.
Yeah. Xargs -0 and minus print 0 and find.
Yes.
So because if you've got any file names that have got spaces in, Xargs will split them up.
Yeah. Yes. So print 0 on find separates them with nulls, doesn't it? And then the -0 on Xargs splits them up at nulls again.
The other one is find. You can actually do some other manipulations with.
You can minus exec and things as well, can't you? Yeah. With weird escaped semicolons and things for some reason. Squiggly brackets. So carrying on building on that command that we were piping together. So we've got our list of directories with the sizes. When I pipe that output into sort. Another thing which you've probably noticed by now, a lot of these commands take short, minus and some letters. They also take long versions. So there's probably minus reverse and something. Rn just means reverse the order and sort numerically rather than alphabetically. So that just gives us a list of the directories with the sizes starting from the biggest, which is very useful if your disk's full and you're trying to work out what's taking up all the space. Adding even more to that pipeline, head just means take that number of lines, in this case 2 lines, so that'll only show us the 2 biggest directories. Tail, as you would expect, is the opposite, just give us the bottom 2, so the smallest 2 directories. Cut, so cut's useful if you've got a file that's split into fields and you want to get one of the fields, so like a CSV file for example. In this case we're looking at the Unix password file, which is separated on colons, so username, something to shadow, user ID, group ID, words, home directory, etc. So if we only wanted to see the username and the user ID, then we can use cut. So -d means use the colon as a delimiter, and then fields 1 and 3, and that does what you expect. Notice it does print the comment out, which is probably not what we want. So what we could do is we could use grep. So instead of just, I can't remember whether I had a use of cat in the previous one. But anyway, you can, grep -v is the opposite of the normal grep. It says return the lines that don't match this pattern. So anything that doesn't start with a hash will print out and then pipe that into cut. And you get the thing without the comment.
-v is normally used
For both, yeah. Yeah.
Which is
Yeah.
confusing.
Not entirely consistent.
Negative.
Yeah.
Yeah. Oh yes, it's something being clever, isn't it? Yeah. Yeah, so you could do that. Another way you could, if things start getting more complicated, this is probably a simplistic case, you probably wouldn't want to do it, but awk starts coming into its own when you want to do more things. So this is an awk command that does the same thing as we just saw, and it will print out those lines. Awk, incidentally, if anyone's wondering why it's called awk, it's named after the 3 people that wrote it, who, according to my notes, are Alfred Aho, Peter Weinberger, and Brian Kernighan of C fame. So what does that gibberish actually mean? So this is that's the command that was in the awk thing. It's easier to read if you don't have it as one line. So awk commands are basically programs, so you can format them nicely the same as you can any other program. So that makes it a little clearer. The begin block runs before it reads the first line of the file, and that just says set the file separator to colon. And then all the other things run on each line, so it says does the line match this pattern? So that's a clear expression saying beginning of the line, anything that's not a hash, and then if it matches that, it'll do the thing in the squiggly brackets which says print the first field, colon, and the third field. So back to where we were right at the beginning. This was that weather munging awk script. So what's that actually doing? If we split that one up, see it's got a pattern matching thing that's basically just saying only look for the lines that have got the right format of data in, ignore the headers. Sets a variable called min to an empty string. Sorry, it doesn't do that at all, lying. That's a double equals. So yes, it's saying if the variable min is an empty string, in other words it hasn't been defined yet, or the second field minus the third field, these are the maximum minimum temperatures, is less than the minimum value, so it only gets into the right hand bit assuming min is defined. So if those things are both true, either of them are true, sets the day to the first field, which is the day number, and updates the minimum to say the lowest one I found so far is this field minus this field. And it'll just run through that loop on every line, updating the values if it finds a smaller gap. And then the last block just says after you finish the file, do this, which says print the day variable. So it's not entirely as gibberish as it looked like. So that's the end of the slides. I should sit down to do my examples. You can all heckle. It's a long way down up. So, right. So I've got 2 examples of just random tasks that you might want to do or not, but hopefully they illustrate some of the different ways you can build things up and kind of the process, or at least what I do of building these things up, which is to start with one bit at a time and then just kind of keep bolting stuff on and looking at it and seeing if it looks vaguely plausible. So I'm in a Git project, and what I want to do is I want to see how many files are in the commits. So I'm interested in, how on average how many files are we committing each time we commit? What's the distribution? How many times do we have ones with more than 10 files, whatever it might be? So git log is the command that will tell us what all the commits are. But in itself, that's not very useful because it's got loads and loads of gibberish in. So we can give that an option, say -1 line. So now we've just got a simple list of commits, 1 per line, which is something we can work with pipes. So we'll pipe that into cut because we only care about the commit ID, the char at the left. So cut minus F1. That clearly didn't work because it's not a tab. I think cut expects tabs by default, so we'll just tell it to use spaces for the delimiter. There we go, we've now got a list of commits. And what we want to do is run some kind of command for each of those. So I'm going to use a bash while loop. And just to start with, I'll just echo the char just to make sure it works. So that seems not to have broken anything. So instead of echoing it, I'm going to do a git show -- short stat, which should tell us what we want to know about that that commit, how many files were changed or not. Well, it does tell us. There's obviously quite a few commits. Just break that. So somewhere buried in here, we can see there is the information we need, which is 2 files changed, which is all we actually care about. But there's a lot of other rubbish in there as well. So that's fine. We use grep to pick out the line we want. So grep files changed. That looks better, except that the eagle-eyed amongst you will notice that there's never any numbers less than 2, because the Git developers, not being heathens, actually bother to put the right error thing, the right message with an S if there should be an S. So regular expression, put a question mark to say we don't actually care whether that S is there or not. For some reason in grep you have to escape that, and I don't quite know why. Neil probably does. No, you shouldn't have to, but you do, because it just pretends nothing otherwise. So yeah, because it's in single quotes, so it shouldn't be. It shouldn't get the shell shouldn't be getting it.
Oh, hang on. Yeah, it's the default. If you did grep -e extended regular expressions, it works.
I tried that, but I'm not sure that the BSD
This is
grep.
a max.
Yeah.
Who knows?
So that's what I thought I could do, grep -e, and it still didn't work. Anyway.
As a side note on that, if you install in Brew, there's a package called GNU Tools.
Oh right, and you get the
If you
the
install
GNU
that,
grep.
you get a G prefaced version
Oh, okay.
of everything.
Yeah,
It's
it's like Gawk and all
Yeah.
those. Yeah, okay, that's quite a good idea. Anyway, so now we've got our list of things. Yeah, they didn't write it, did they? So it's just BSD that it came from.
Blame that, man.
Yeah. Right, what's my place? What am I doing now? Right, so we've got our list of lines, and all we actually care about is this number at the beginning. So we'll use cut again, minus F1, and we know that we're going to have to tell it it's a space, so we'll do that straight away. And now we should get blank screen. Hooray! Okay, so it's not minus F1 because, if you just run it again, there's actually a space before each one, so it's actually the second field. I'm not quite sure what the first field is, but we'll just go with it and say we want the second field. And hopefully, there we go. We've got a bunch of numbers. So what we now want to do is find out how many times each of those numbers occurs, and that will tell us. The command for doing that is called unique, with no UE, so unique like that. And if you say unique minus C, instead of normally what unique would do is it would just throw away duplicates and it would just give you the unique lines. Unique minus C tells you how many of those lines there were, but unique assumes that its output is sorted, its input, sorry, is sorted. So we'll pipe it through sort first, using minus n because they're numbers. Otherwise 10 would come before 1 or whatever. Yeah, we'll go 1. Yeah, you know what I mean. So I missed a pipe. And now you'll notice that it's doing it all in one go, because sort can't work line by line because it has to wait until it's got the whole input before it can give you a sorted output. So that's one of the exceptions to the sort of one line in, one line out rule. But we do now have some stats that says we had 202 commits with a single file, 97 commits with 2 files, all the way up to 1 commit with 49 files, which I think actually was the new Rails project commit. But we can play with that a little bit more. So it'd be nice to have like a little bar chart. So let's use awk to try and generate some kind of chart. So we'll pipe it into awk, and we'll start off just by printing the number that we're the number of commits. That's the second field. The one on the left is the count of that number of commits. So $2. Let's just do that to start with, just to make sure it works. Perhaps should have picked a smaller project. There we go. So we've just got those numbers, and then so they're not formatted very nicely. If we want a bar chart, it'd be kind of nice if those numbers lined up on the right rather than the left. So we use printf. Anyone who's ever done any C will remember how printf works. So say %3i, $2. Hopefully that should give us a nice formatted output. Or not, I missed a new line. So now they're nicely lined up, so if we draw a bar chart next to them, it won't be offset when the numbers change. So how do we draw our bar charts? Well, first of all, we know that we're going to have to print the number and then something and then a new line, so we'll do that bit because that's the easy bit. So if I take my new line off here, we'll have another block in, so all these blocks in awk are operating on every single line because we're not giving them any kind of pattern match or line range or anything, so something, but we don't know what, in another block. And then right at the end, we'll just do a print of an empty string just to force it to put a new line on the end. So that shouldn't have any effect at all on our output at the moment, which it doesn't. And inside awk, as I said before, it's a programming language, so it's got basic for loops. So do another C style, good old-fashioned I equals 0, I is less than. So in this case, we want to loop up to the number in the first field, which is the thing that told us how many commits we had with that number of changes. So that's $1, I++. And for each of those, we want to print. I'm going to do printf because I don't want it to do print does an automatic new line. I'm just going to print a hash character, and then hopefully that should just give us a lo-fi bar chart. Which it does almost, except we need a space, and also it's kind of a bit crap because it's sort of wrapped, which you don't expect bar charts to do. So let's fix both of those things. First one's easy because we just want to put a space in here. And the second thing, I didn't mention less before. Less is just a pager that just you can print file through less and it will just give you one page at a time and you hit space to get the rest of it. But less has an option -S that says don't wrap the lines, just let them go off the edge of the screen. And hopefully that should give us our finished bar chart. Yeah, there we go. Apart from, I think that might be left.
No, scroll to the bottom because it's the.
Yeah, it's just, oh, of course it's just scrolling. Yeah, that was the previous command. So yeah, when I did it at home I had a bigger terminal so I can get there. Okay, so that's the first example. The second example.
That doesn't seem to be including that space.
Sorry?
That doesn't seem to be including the space.
That's a good.
Less, so it's reverted to the previous screen.
Oh yes, yeah. Yeah, I think, does less have another option that says don't throw it away when you finish, because that always really annoys me when you like man pages and then they go away. Anyway.
That's what more's for.
Yeah, I always use more because I'm old-fashioned, or just old. Didn't have less in my day.
Yeah, I think grep one is if you was thinking about if you use egrep.
Oh.
Or grep, probably capital E.
Yeah. So I think I tried egrep and it's not installed. And grep capital E, I think, says there's no such thing.
So it is a very basic.
Yeah. So yeah, you need the GNU grep. So like Adam says, yum install brew install GNU tools. So the second example, equally randomly, let's say we want to find out how many times each class in a project is referred to. I should probably have said before, if anyone doesn't have a clue what I'm talking about, then please interrupt. And it's a bit late for that example, but this is a Ruby project, so we want to find how many references there are to each class. There's probably tools that would do that, but for the sake of argument, let's say we're going to do it with shell stuff. So we're going to look in the app directory and the lib directory, because that's where the code lives, and we're going to look for anything with a name of something.rb. Seems to work. We've got a list of files, and for each of those files, we want to search all of those for class definitions. So we're going to do xargs grep class. So you can see it's kind of found a bunch of class definitions, but it's also found other things that aren't really anything to do with class names. So we need our pattern to be a bit better. So we'll say start at the beginning of the line, any number of spaces, and then class, and then a space after it. So this looks far more likely that all these seem to be actual class definitions. So we're fairly happy that's working. So where are we? Right. So actually, we only care about the actual class name. So we'll switch from grep to awk so that we can just print out that that field. So we'll say awk, tell it to look for that pattern, and print the second field. So there we go, that's our list of classes. Now, looking at these classes, I immediately notice, for the purposes of the example, that the DNS record class is missing. And the reason for that is if we look at the definition for the DNS record class, it's defined as a value, which isn't, it is a class, but it's not defined using the class keyword. So that's kind of a special case. So we want to include, maybe there's a bunch of those as well. So in our awk command, we've already got something that says print out the second field or anything that's a class definition. We'll add a second pattern that says look for anything that's value.new and print out the first match. So that's going to be that string there. So now somewhere probably there's a DNS record, don't have a word for it, somewhere. Anyway.
I don't think you printed it. No.
You're right. Don't take my word for it, because I lie. There it is, DNS record. So that was mainly just an example of the fact that with awk you can tell it to do different things with different pattern matches, rather than having to do two weird regular expression things. So we've now got a list of classes, and we're going to use a while loop again to go through them. I'll read class do, and then for each of those classes we want to find all the files that mention that class. So find, and then the same directories again, applib minus name star.rb, and then we use xargs to say search all those files. Xargs. So we're going to use grep, say, give us a count of the number of times we find that class variable, whatever the class variable is set to, which is once through for each of these. How many times do we see that string? Okay, it looks like that's probably not quite what we wanted because we've got far too much output. So what's actually happening here is it's searching every file for every class, so you're getting some kind of combinatorial thing. So what we actually want to do is to take the list of file names. We don't actually care about the file names, all we care about is how many times we see that class mentioned. So instead of searching each file, we want to take the contents of all the files as one massive long file and search through that. So this is a non-useless use of cat, because now, if I can remember where I need to put it, so after my find, instead of doing xargs grep, I can do xargs cat and pipe it into grep. So that means that the file list is now an arguments to cat instead of grep, so it'll just spew them out in one long line and then just grep them once. So now we've got the numbers, but we have no idea which classes they're talking about. So that's easy enough to do. In the while loop, we can just echo it, which is almost right, except that my grep is slightly wrong. Yeah, well, that's not working. Oh, it's because I put it outside the do. That might be, there we go. So that's almost right, but it's going to be really hard to parse this because they're on separate lines. So we just give echo the -n option that says don't put a new line. Again, that's still a bit useless because it's got no space, so we'll just put that in a string with a bit of space after it. There we go, we've now got something we can work with. We've got a class name and a number. So again, we'll use sort to put them in order. N for numeric, R for reverse, and we actually care about the second field, so we'll say keyword 2, or whatever K stands for. So that looks reasonable. We've got the highest one at the top. It's probably slightly wrong because it's quite possible that the word user appears in some other things, but we'll gloss over that for now. The other thing that's slightly suspicious is all these ones that have only got one reference, and these are controllers which are never usually referenced at all, and the reason for that is we're actually finding the class definitions. So we'll just kind of treat and we'll just subtract 1 from all the numbers, which is probably not quite right, but let's imagine we just want a rough answer. So we'll stick an awk in before the sort. So we want to print. So we'll print the file name, blank string, and then the number -1. And then we'll pipe that into sort instead. Have I missed the quotes? Yes. So now those go down to 0. We actually don't really care about the zeros, so that's fine. Awk just lets us say only bother about the lines that have a second field that's more than 1. And that's it. Any questions? So I'm going to say, how do you test it?
Any of that?
Write it down. Mostly, you remember the simple bits, and then Google.
Seeing as you're the person doing the talk, how do you write tests for this?
That's what I just said. I just told you so. You don't. Well, you could do, I guess.
Is there like
I think there's a bash unit.
Yeah.
Yeah. I guess the type of things that I tend to use it for is one-off things that I'm just doing and then throwing, like I've got a list of names and emails and things, and I want to generate a. Yeah. So yeah, I don't write tests because it's not code that I keep, but it's just stuff that I literally do in the command line until I've got the answer I need, and then that's it. Throw it away. Sorry?
Do you version control those scripts?
Only if it was something I was going to want to do again. Quite often it's. I mean, if I really did want to have these numbers, and yeah, I'd probably put that.
Like on starting out, one of the things we're saying at work is you should version control everything. So if we're looking at something like Git, for example, you put that into like a snippet. For my view, that's brilliant because you probably wouldn't do it because you think, I can write that in 5 minutes. But for me, that's probably a good example.
I think
where you go and look at how you
definitely. If it was something that I knew I'd want to do again, then I would put it, stick it somewhere that was controlled. But yeah, history will just give you, massive.
Apart from when you run out of history.
Yeah. But yes, you can use that for short term. At least if you think, oh, I should have versioned that, you can usually go back and find it and then save it as either save it as an alias or. Yeah. Well, it depends how you set it up. Yeah.
Yeah, it depends on your configuration.
Yeah.
Or some default configuration
Yeah.
as well. We'll only keep the history for that current session, and it'll dump it as soon as you create a new shell.
Annoying.
Yeah, and if you have different sessions, you can have different history files. But
Yeah.
Some of them you can go. You can set it up such that it shares the history across the.
Yeah, and that seems to quite work properly, though, does it? And
back to the very original point where they were saying it was faster than Hadoop.
that was the original point. Oh yeah, that was yes.
Right at the very, very beginning. Is there an argument which says that you could put a script like this into production? At the very, very back end, if you would make sure you parsed everything all the way in?
Yeah, there's no reason why you shouldn't use it for production code, and then you probably would write tests for it, I guess. But I mean, the thing about it being faster than Hadoop was because it was something that you should never use Hadoop for in the first place, I guess. But because if you've got a couple of gigabytes is relatively small, but it's a lot of data to ship off to Amazon and back again. And if you're running something that you could just run locally.
Fast on an Oracle database is not unusual either.
Mm,
Something exactly like that at the moment, where I actually dumped out. It was a gig of records, in the end, so several million records into a text file, and it was actually far easier to do the processing workload.
Something that's worth noting is things like the while loop. If you do a while loop and run, some of these things are shell built-ins, but most of them are separate programs effectively. So if you do something that involves you spinning up a new instance of find and grep and everything for every line because you're doing it in a while loop, that's going to be really slow, which is why Xargs is usually much, much faster. But some things doesn't really work.
Do you have shell scripts in production? Absolutely.
Yeah, why not? Although I guess a lot of it you could do with Perl or Ruby or something as well.
I suppose the other one for doing the Xargs with the number of the batch numbers is, for example, if you've got a very large number of files, but it's faster to do it in say 100 at a time rather than otherwise you sometimes find that you get too long a command line.
Yes, there is a limit to the
Or it's the job of Xargs to make sure it doesn't break the command line.
Yeah.
But you're quite right. If it's too much to process by the command you're but Xargs will break it up based on what it knows the actual limit of the command line is.
So it does that.
Any more? No?
Thank you very much.
That was vaguely useful.